Okay, so seems like forever since we were in this room together. I remember 3 bouts of this kind of weather, and I haven't liked any of them. This one's been the worst, probably because I'm 2 decades older than the first one. I looked through your design solutions. It seems to me you have a good handle on this. Honestly, the major question I had from most people was on why are there only 2 entries on the form. It's like, it's a form. Fill in what you need. So anyway, any specific questions on the design solution? Pretty straightforward. You know, my goal is to get you thinking through what you have to accomplish with the dial plan, where calls have to go, who needs to talk to each other, that sort of thing, and then think through those design controls that we have. And that was the main purpose here. I'm aware that we haven't talked about how to get outside of this switch yet. That's fine. But you've already defined, if you think through it, you've already defined how to do that. We just have to learn how the interfaces work. How would you send calls off of this switch based on what you've already done? What calls leave this switch?
Local area,
Local exchange, right. Okay. Any others? I heard 2 of the 3 that I identified. What about other sites? They're not on this local switch.
That's what I meant by local network.
Oh, okay. I misunderstood you. Local exchange, so calls to the town surrounding us that aren't on our network, to our local exchange carrier. Long distance, same story, only further out than our town. Excuse me. And then on-net calls to other sites. So all of those you defined by call templates, which means now you can deal with them as distinct properties. You've, in essence, if you want to look at it from the computer science point of view, you've, in essence, sort of created an object that you can deal with. I know it's stretching programming a little bit, but basically now that we identify the way those calls look in a template, I can now use that template to control where we're going. We are going to start looking at trunks here in a couple of weeks. Before we had our forced vacation this week, we were actually going to look under the hood of how SIP registration works. You know, we've sort of done the, you start your system, you start your phones, then a miracle occurs, and these phones are all registered with the system. We've talked about them being registered. We've talked about them being an identity. We really haven't looked at how that happens. And we're going to do that before we move on, before we leave the local system. As I mentioned before, local gets to be a harder and harder term to deal with as we talk about the way these systems work. So that's why I'm kind of keeping us in a fairly tightly bounded area here for a little while. What I want to do to finish this lab up, I have a procedure for you. Hot in here. I have a procedure for you. Basically, you're going to take your design and you're going to put it into hardware. You're going to go sort of back through the lab you did before and adapt it to your dial plan. The other thing that you're going to do, we've set up a TFTP server. So instead of saving to the local switch now and all the problems we had with that, you're going to transfer out to a TFTP server, which also has the advantage that if you need to stop in the middle of what you're doing, save out to the TFTP server, go back in, load from that, carry on, save out again, and it'll overwrite the old files. So that's a place you can do intermediate saves if you like. Anybody not familiar with TFTP enough to know what I'm talking about? I hope you all are. Okay. It's trivial file transfer protocol. It's simply an automated way of backing up a file to another server without having to know where that server is other than an IP address. So you say from your command line, and I actually give you the commands to save it out, and I'll put a note up. I didn't actually show you how to load one because we haven't done that yet, but it's just the inverse of the command. from the command line, you do copy whatever the file name is. We're going to do startup-config, copy startup-config TFTP, and it's going to ask you for an IP address. It's going to ask you what do you want to name it on the other end. You feed it those two things, and it'll transfer it across. When you want to pull a file in, you just invert that. You say copy TFTP startup-config. Ask it. You give it the address. You give it the original file name, and it'll bring that in. So, very, very useful. Like I said, I didn't think about your loading it up in the intermediate. I really don't think it'll take you that long, but I'll put up a note about how to do that. So, if there aren't any questions on the design part of this, what I saw looking through them looks good. Okay, then we'll look through this. So on the first piece of this, usual outline, basically it's telling you what you're going to do. We're just taking your lab solution. I want you to use the solution you came up with. Don't change it. Okay? If it doesn't work, I want you to troubleshoot why. Use your lab solution that you turned in for the problem, and I want you to implement it in hardware. If you turn to the second page, we're looking at the same lab infrastructure we've been using. The difference is we're going to assign only some of your numbers. I gave you a range of numbers for each site. You are only programming the main site. I do want all of the templates in, long distance, Lex, all of that. Everything you have in your solution, I want in there for templates. In terms of actually putting in accounts, the only accounts you're going to build are 3 of them. The operator, which will be on the IP706, the hard phone. VM1 soft phone is going to be one of your executives. I want it to be the first one of that range. And VM2 soft phone is going to be the first of your regular users. That'll let you test the calls on your class of services. So what you'll do is go through, put in all the controls that we learned last time to implement your dial plan. Again, it needs to match. The way I'm going to grade this is I'm going to pull up your design and I'm going to compare it to your config. So if you change your mind now, the part of the grade that is taking your config and putting it in hardware doesn't match. Okay, so use the config you have. I'm honestly at this point not as worried about whether or not the config works is that you realize which of these pieces goes where in hardware. That's what I'm after. Okay, so that's what I'm going to be looking at. You're going to have lots of practice on making this work. Believe me, you'll get there. So. You're just doing the main site, correct. The design, one of the design criteria was that all of the sites dialed the same way. Okay, really the only added piece that you are doing is how to use the TFTP configuration. The way these systems work, they of course are waking up however they were left before. So my suggestion to you is that you go through that factory default, set that up the very first piece when you log in, and then start from a clean platform. To get to the TFTP server, the world basically looks like this. There is a routed IP cloud. If you look real close, that's going to look strangely like a single router in this lab. And we have several infrastructure pieces that we'll be using throughout the semester, and they're off on their own subnets. The first one you're going to use is TFTP, and it is 172, this is the network, 172.226.202.0. This is a /24 network. There is a routed interface on that router that is .1. Everybody's using the same TFTP server. The server itself is .2. Okay? So that's where you're going on this. Obviously, to get from your lab station, you're going to have to cross a routed interface. And since you're waking up with a factory default, we have to change that WAN interface connection. It's very, very similar to what you used in Cisco. Let me walk through it just to be sure we cover all the details. So this is the NetVata 7100. The WAN interface is ETH 0/0. Okay? And right now, your factory default configuration doesn't have anything on that. What you're going to do is make that 10.ls, and you'll notice those are in big red letters. That means don't type ls. .1.2. Okay? The routed interface over here is 10. Whatever your lab station number is, single digit, 1.1. Okay? So you're going to build this connection. This is a /27. And ADTRAN will, I don't know, does Cisco take CIDR notation now on routing commands and interfaces? Does it? Okay. I didn't, the last time I did anything eyebrow deep in it, it didn't. So.
It does on 6, but not on 4.
Okay. ADTRAN does. You can do it the old way if you're more comfortable that way. But /27 is what we're using for this network. I have you write a description because I want you to get in the habit of doing that, to document when you do configs. I want you to start putting in information that helps people to come after you. So the description on this is going to be Metro E WAN. I think I said interface, didn't I? Connection, yeah. ADTRAN interfaces normally wake up, but just to be safe, we're going to do a no-shut on that. And we're going to exit back one level, and you're going to put in the default route. Same syntax you're used to. IP, route, 0, 0, 0, 0, 0, 0, 0, 0. And then you're going to put in your wide area net interface on the far side. So 10.ls.1.1. Okay? Once you get there, it'll handle routing to any of the infrastructure stuff you need to get to. Okay? When you get that built, I'll walk you through specifically testing that, and I want you to test each of these interfaces. Okay? I've built it. I've tested each of the lab stations. I'm comfortable enough to hand it to you. I still want you to test the interfaces for me just to make sure I don't have any bears in the woods after things have shut down and started back up. So that's what you have in there. If you run up against, if you start doing the ping test, and I'm having you ping this interface, then this interface, then this one, and then this one. If you run into trouble on any of those, you guys know enough IP troubleshooting to go back and check routing tables and all that sort of thing. Please do that. If it doesn't work, I don't expect this to be a case, but if it doesn't work, drop me a note and give me the troubleshooting information you have. I can get here and here. I can't get here. I'm in pod number whatever. Okay, I don't expect that to be the case because I've checked every one of these, but it doesn't hurt to put it in. Once you get there, and the last, number 13 actually is the server interface. Once you get there, Then you're just going to use that syntax I talked about. So we're going to name the file, copy startup config to TFTP. You'll put in the IP address of the TFTP server. I want you to use the file name lab3 underscore username, that's your NetLab username, underscore CFG. Okay. I hesitated to even say this, but I'm going to just because my sense of humor was worse than any of yours when I was in college. Please don't overwrite somebody else's files. It was funny the first 20 times I saw it, sort of. It's really lost its gloss right now. So, I know you can. I really don't want to go to the trouble of putting in controls so that you can't. I will if I have to. Let's don't. Okay. Add a note to this. I will change the lab so this is in here. After C there, when you see receive notice that the transfer was successful, I want you to do something. I want you to do copy TFTP startup-config. In other words, I'm going to have you copy the file back. Just invert the names on the number 15 command. Copy TFTP startup-config. I'm going to have you copy that file back up. See if it's there. Okay. It'll ask you for the IP address. I'm sorry?
Copy TFTP startup-config.
Correct. And it'll ask you for the IP address of the server. Same server, of course. It'll ask you for the destination file, or it'll ask you for the file name that you want to get it, that you want it to get, and that is that lab3 underscore username underscore config. And you're copying that to TFTP. I'm sorry, to startup-config. I just want to make sure it works. Okay. Questions? Yeah.
The last section of the address,
Mm-hmm.
it may require a I'm not totally sure.
I think I have it. I think actually I put it in here. Actually, I did. /27.
I mean,
So-
the actual command, not the slash notation.
No, it takes that. Yeah, that's why I was asking. It'll take the other notation, but it'll do cider just fine.
Okay, so what was the destination file name for copying the startup config?
Tell you what, I'll put a lab up that has D on there with this, but it's when you're copying from TFTP, it's going to ask you for the source file name. In other words, what's the file you're coming from TFTP with, and that's that same one you saved before. Okay. Since we have missed most of last week, and I had to miss one before, we're actually not way far behind where I wanted to be. We're a little behind where I wanted to be by spring break. I'm not really willing to jump into something hugely new before spring break. So what I will do next week, we'll go over this, make sure everybody's good on it, see if there are any questions. That'll be Monday. I am going to go ahead and Wednesday outline what we're talking about. I'm going to give you a little bit of reading in lieu of class on Friday. I figured you guys wouldn't mind that as a trait. Okay. When we get back, we'll pick up on SIP under the hood, and we'll work through our labs that way. Here's where we're going in the next few weeks. We're going to look at how SIP registers. We're going to look at how we can look at the SIP traffic. I know you can use a protocol analyzer, but I want you to learn how to read the SIP protocol as it goes through. We are, as I mentioned in the intro to this class, we are using SIP in the lab. It is far and away the most installed new installation protocol now. It is not the most installed protocol. Cisco's proprietary protocol called Skinny has more endpoints installed than anything else, but that's because Cisco has 60-something% of the market. It Skinny and SIP are very similar, and Cisco is moving to SIP. It's becoming a SIP world real fast, so we just decided not to do, we don't do proprietary protocols much in this program anyway. But we're going to study SIP. We will at one point compare it to other protocols that are out there. Realize that you're accomplishing the same task on similar networks, right? You've got an IP network. How different can IP networks be? The view from 30,000 feet. You know, they all have routers. They all have layer 3 switches. They all use IP addresses. It's not that hard to move from one to the other. When you're accomplishing the same thing with an application, like moving voice from one point to another and specifying where it's going and all that sort of thing, we're accomplishing the same thing. So the solutions accomplish similar things. They just go at it with a little bit different point of view. And we're going to look at some of those differences in the for what it's worth category. My bet is those of you that end up touching voice will use SIP. That's held true so far as we've been asking around, so that's why we're doing this. After we look at SIP under the hood, we're going to start looking at outside a single network site. We're going to look first at how we build trunks in SIP, and those will be trunks across an IP network. Then we're going to start looking at trunks that talk to the PSTN world, because as I've said, it hadn't gone away yet. It will. You guys will probably see it go away in the next 10 years, but it hadn't gone away yet. So we're going to look at how to use those interfaces. Okay. By the last probably 4 weeks of the semester, we're going to be at the point where we're going to do a fairly in-depth design and installation. Your lab stations, as you saw on the big version of the sheet, have several sites. And basically what you're going to end up doing is designing a solution that feeds those several sites and gets to the PSTN or my version of the PSTN and all of that. So we're going to start spending more time in the lab than we have. This class is pretty front-loaded on theory because you really haven't had any of this before. Yeah. Okay? Have a great weekend. We'll see you Monday.